Welcome to my channel. Today we look at more other examples of integration by algebraic substitution. In one of our videos we had looked at how to integrate using method of substitution. So we just continue with that lesson today, looking at various other examples. So I began by some two formulas of how to integrate here. And these formulas will be very much important to some of our examples. Now, the first formula is that, you remember in our first video, we said that the rule for integrating, if you're given a function, if you're given the integral of x raised to n dx, we said that the rule for integrating this would be x, then we add 1 to the power and divide by the new power. That new power is n plus 1, then add the constant of integration. We said this rule will not apply for this when n is -1. So then how do you do it when n is -1? This is the same as this. This is the same as the integral of 1 out of x dx. How do we integrate that? And the solution is here, that the integral of 1 over x will be given as the natural logarithm of x plus t. In fact, it is important that this natural logarithm, this x be in absolute values. It's important that it is placed in these absolute values. And therefore, what I therefore mean is that if I'm given to integrate 1 out of x dx, my answer will be the natural logarithm of x. The natural logarithm of x. Then I'll add the constant of integration. What about the integral of exponential x dx? Now the integral of this e raised to x to dx would be given by e raised to x plus constant of integration. So these are the two formulas that I want us to begin with, so that in some of our examples we want to use them. Now, so let's look at the first example in our today's class. We're using substitution, and you'll discover that the questions we are tackling today are slightly different from the ones we tackled in the previous video. So the question is, integrate this, and this is very easy. You know what we know how to do is this. We know how to integrate x raised to any power. We know how to integrate x raised to any power. And we know that this will be x raised to n plus 1 over the new power plus a constant of integration. But what I have here is something more than that. It's not x, it's a bigger value. So what I will do, I'll equate this, whatever is in bracket, to u. I'll say let u be whatever is in the bracket, 10x minus 2. And then after that, I differentiate this. And when you differentiate this, on the left side, as we did in our previous video, will be du, and on the right side will be 10 dx. And then at this point, we would want to make the x the subject of the formula by dividing both sides by 10. And when that happens, you get du out of 10. Now, so the question is now, how do we integrate this? To integrate this, we use substitution. That instead of 10x minus 2, we put u. And instead of dx, we write du out of 10. So what does that become? Then the integral, that integral now will be written, instead of 10x minus 2, I'm writing u and raise it to power 5. And then instead of the x, I'm writing the u out of 10. And then at this point, we will take the constant outside the bracket, and the constant you can see is 1 out of 10. Now take it outside the integral sign. So when I take the constant outside the integral sign, what I have is u raised to 5 du. This one, now we can now do this comfortably because we now integrate it using this rule. We can now integrate that comfortably, and this would be 1 out of 10. The integral of this would be u raised to 6, then divided by the new power, which is 6, and then add the constant of integration, so that your final answer, or the answer, not only the final answer, but the answer will be u raised to 6 out of 60 plus q. So you're only left with one task, and it's not hard, it's just substituting u, because u was not in our original question. U was not here, so we substitute u was 10x minus 2. So that means our final answer, this integral, therefore, is 1 out of 60. U raised to 6, instead of u, we are writing 10x minus 2, then raise it to 6, then add constant of integration. So it's very easy doing this integration. And of course, I had already done this, so let me just show you the steps. And the same steps I've already showed you, but let me show you how I did it. And I do it for the rest of the questions, the rest of the examples. Now, so just going through the steps again, what we want to integrate is this. This is what we want to integrate. But before we do this integration, I've said, for us to integrate this, let u be the one inside the bracket, and then differentiate on both sides. Du is 10 dx. Then make dx the subject of the formula by dividing both sides by 10, and we have dx is equal to du out of 10. Now we are now ready to integrate. You come back to your question. Which is here, and instead of this, write u and raise it to 5. Instead of dx, write du out of 10. Then take the constant after the integral sign, 1 out of 10, integral of u raised to 5 du. Integrate this u raised to 5 by adding 1 to the power and dividing by the new power. And when that happens, you get 1. In fact, it will be 1 out of 10 times u raised to 6 divided by 6, then plus constant of integration. From this step, you can see how I got 60. 1 out of 60 raised to 6 plus 2. So you only need now to substitute your u here with the equivalent. U was 10x minus 2. So, and this becomes your final answer. That becomes your final answer. It's very easy doing integration so long as you know the steps. Now let's look what the next example that we're supposed to do is almost similar. So for this question, I'm just interested in this. I'm just interested with this 7x, and whatever is here is x squared. Whatever is x squared, and this is x. So that is very interesting, and you'll see how it will help us to how we shall do that. So let's do it. That's the question B. So again, this is what I want to do. So I'll call this part u. I'll call this part u because I want it to assist me to cancel this x. This is higher This is x raised to a bigger power. This is x raised to a smaller power. So I will take this to be u, so that I have an x in the denominator to cancel it. Let's see how it works. So let u be whatever is in brackets. Differentiate on both sides. On the left side you get it du, and on the right side you have 10x dx. And then make x the subject of the formula by dividing both by 10. And when you divide both sides by 10, you have dx being equal to du. Now divide both sides by 10x. So you have dx being equal to that. Now from there again we go back now to our integration. This is what we were supposed to integrate. And we just substitute that instead of this you write u. 7x you can see still there, multiplied by u raised to 6 times dx. Dx is du out of 10x. X will cancel with this other x. And you can see the constant is 7 out of 10. We take it outside the integral sign, 7 out of 10. The integral of u raised to 6 du. So we can now easily integrate this to be u raised to 7 and divide it by 7. And remember this was 7 out of 10. So this 7 will cancel with 7. Then you add a constant of integration. So what are we left with? We are left with u raised to 7 out of 10 plus c. But what was u? Just go back to where your u was. Your u was 5x squared plus 7. So this is our u. Raise it to 7. Then divide divide that by 10. Then add the constant of integration. That's what I got. That's what we get when you do that. So let me show you the next one, the next example. The next example, we are supposed to integrate this. We're supposed to integrate this. And what I'm saying again, I'm saying that this one is bigger than this. This one is bigger than this. So I let u be this. I let u be the one. I let u be equal to 2x cubed minus 6x squared. So let u be that and differentiate on both sides. So only differentiate this part, you get 6x squared, and this part gives you negative 12x. So du is equals to 6x squared minus 12x dx. Make dx the subject, just the same way we've been doing, by dividing both sides by this. So dx will be du divided by this, and you have this. Now we go to our integral. And remember that this part it's u. This part is u, so we just replace u there. So you can see that our integral, therefore, I still have this part here. But instead of this, I have u raised to 5. Of course, that was our u. So it's u raised to 5. Instead of dx, I have the equivalent of dx, which is here. Du out of 6x squared minus 12x. We can use some just simple factorization, because you can see that whenever I can factorize this, that I have the numerator being the same as some part of the denominator. So that means if I were to factor 2 out of this denominator, then it would go into 6x squared 3x squared times, and 2 would go here 6x, and that is what I in fact I have in the denominator. So what I have in the numerator. So the numerator is here times u raised to 5. This is also I'm using them to imply multiplication. then times du. So this part is what I factored 2 out, so that this cancels that. So what am I left with? I'm left with the integral of u raised to 5 du, and this constant can be taken outside. The constant can be taken outside the bracket, and this is what I have. And this can be integrated to be a half. Just add 1 to the power to get u raised to 6 and divide by 6, then plus c. So this part gives you u raised to 6 out of 12 plus c. That's what I have. So we are left with the substituting back your u. So when you substitute back your u, which is 2x cubed minus 6x squared, and then raise it to 6, then I divide it by 12 and add c. Of course, somebody may want to leave the answer at this point, but this can be simplified further. This can be simplified further. So just show the step that I done before. So this is the part I'm talking about, that one may want to leave it at this point, but it can be simplified further. So how did I simplify? I just noticed that whatever is in the bracket can be factorized. And then 2x squared is common. 2x squared is common. So let me just show you what I did. I have, if you have 2x cubed minus 6x squared and raise it to 6, this can be written as 2x squared. 2x squared is common here, and 2x squared would go here. Will go here, x, go there, x times, and 2x squared will go here 3 times, and then the whole of this thing raised to 6, and then divide by 12. All of that thing raised to 6 and then divided by 12. Now, when this happens, you know that if I have 2 times 3 raised to 6 is the same as 2 raised to 6 times 3 raised to 6. It's the same. It's the same thing I'm doing here. That this will be the same as 2 raised to 6 x. This is raised to 2, then I raise it to 6, and it will be raised to 12. Then this other one will be x minus 3 raised to 6 out of 12. And this one is 64. 2 raised to 6 is 64. So in fact, what is 64 out of 12? This is 64. So let me just write it as 64. Just write this as 64. So this is 64. And we know that 4 would go here 16 times. And 4 would go here 3 times. And so this answer here, this answer is the one you're seeing, plus constant of integration. That we have 16x raised to 12 into x minus 3 raised to 6 out of 3 plus 6. So this one I just factorized this. Although I had already said one would want to leave the answer at this point, but this answer can be factorized further, can be simplified further. Let's look at the the next example, and I've done it. For the next example, we want to integrate e raised to 7x. And remember, we had already said that the integral of e raised to x, or e raised to u, du is e raised to u. So that means whatever is here, I must make it be u. Whatever is here, I call it u. So I say, let u be 7x. So if u is 7x, then differentiating on both sides, the left side will give me the u equals, so the right side will give me 7dx. Then divide both sides by 7 to make the x the subject of the formula. And that means the x is equal to u of 7. So therefore, this integral, we just substitute back what was u, we substitute it back here. And so this will be the same as the integral of e raised to u times, instead of dx, I'm writing du out of 7. Because that's what we have. Du out of 7 is the equivalent of dx. So we substitute it. Now at this point, as we've been doing, take the constant after the integral sign. We have 1 out of 7, the integral of e raised to u du. So when we integrate this, we already know that the integral of this will be e raised to u plus c. But what is u? U is or u is 7x. Or u is 7x, it's 1 out of 7 e raised to 7x plus c. Now again, that means that we are in a position to do such questions mentally, so that in cases where we have long workings and this appears, we can do it mentally and reduce on the working. So what I'm saying is that there's a 7, there's a coefficient of x here, putting the coefficient of x here at the power, and I'm saying that how big as 1 over 7, and then the rest remains. So that means that if I'm given to integrate l times e raised to bx, I can do this mentally, that my result will be a out of b, e raised to bx plus c. So this one you can do it mentally to reduce on long workings. So you get this constant here over the coefficient of x here. So a out of b, then e bx, then add constant multiplication. So I want to do that in the next example, so that we reduce on the workings. So in the next example, our next example is this. So this next example, I can say that I have 3t as the power, and I have 5 here as a constant. So it will be this 5. This is now my a and this is my b. This 5 over 3, and the rest remains. This 5 over this 3, and the rest remains. But if you want to do it just the same way we did the other example, you can still do, where you would say let u be 3t plus 7. And remember that after doing this, you have to differentiate both sides to get du being equal to 3dt. Now, let's look at this other example. This example can also do mentally, but we have to take e raised to 5m to the numerator. You have to take to the numerator. So you can see I've taken it to the numerator. And if it was minus, when you take it to the numerator, it becomes plus. And if it was plus here, when you take it to the numerator, it becomes minus. So if I were to take it to the numerator, I would have e raised to negative 5m. So I want to do it mentally without much workings. Let this be. So what I know, this is what I have. This is what I have. This is what I have. If I have to take the constants outside, this is what I have. But to integrate this, we said that I will take 1 out of this, 1 out of this -5, and the rest remains. So that's what I will write. 17 out of 12 times 1 out of -5. And then the rest remains. The rest remains. This reduces on the working. And you can see that this is -17 out of 60. -17 out of 60. E raised to, oh, I left this integral. This integral sign was to disappear at this point. This integral sign was not supposed to be here, and it was not supposed to be here. So it's supposed to be -17 out of 60, e raised to -5m plus constant of integration. The same thing. So if I want this to be positive, I take it to the denominator, and this is the answer. So my answer is supposed to be, if I want it positive, I would have that 17 out of 60 e raised to 5m plus c. So again, remember that this integral is not supposed to be here. So let me look at another example. Now this time I'm integrating this, and remember that we said at the beginning that the integral of 1 out of m dm would be the natural logarithm of m, and this m we are putting it between the absolute signs, and then we add constant of integration. We add the constant of integration. So for this one, it's very easy. I just took the constants outside, and the constant is 17 out of 5. When I take it outside the integral sign, I have 17 out of 5, the integral of 1 out of m to the n. And this, we already know the result here. So 17 out of 5, and the integral of this one is natural logarithm of m, then plus constant of integration. So that is how we do that. That's how we do that. So let me look at this other one. Let's look at this one. Now I want to do this. I want to integrate 7 out of 13 theta plus 4. So I know how to integrate 1 out of u, but this one I have to make it, I have to call it u, I have to call this one u. So I say let u be 13 theta plus 4. Then integrating, differentiating both sides, I have du equals 13 d theta. Du equals 13 d theta, and make d theta the subject of the formula by dividing on both sides by 13. So you have d theta is equals to du out of 13. Now come and integrate. The integral of 7 over 13 theta plus 4 d theta, I will substitute this one with its equivalent, which is u. So it's the same as the integral of 7 out of u. D theta is du out of 13. Take the constants outside the integral sign. We have 7 out of 13 outside the integral sign. We are left with 1 out of u du. This we know how to do. So we know that this will be ln of u, the natural logarithm of u. So 7 out of 13, natural logarithm of u plus c. Now just bring back here u, because u was not in the original question. When you bring it back, this is what you have. That's what you have. So get 7 over 13, natural logarithm of 13 theta plus 4 plus constant of integration. Now, so finally, we look at this other one, we look at this. And this one is very easy, that we have t squared in the denominator and we have t cubed and then t. So we say that whenever we have this variable in terms, we begin by first of all dividing it. So when you take 17 t cubed divided by t squared, and then plus 2t divided by t squared, what you get, this part will give you 17t, and this other part will give you t equals 1t without 2 out of t. So that's what I say, that first simplify it as the 17t plus 2 out of t dt. Now this is now what we integrate, and when you integrate this, what you get is the same as integrating 17t dt plus integrating 2 out of t dt. But this one, you know, is 17t squared out of t, and this other one we know that is the same as 2 the integral of 1 out of t dt. So what is the answer? The answer here is 17t squared out of t plus the integral of this one's natural logarithm of t, so it will be 2 ln of t plus constant of integration. And so that is what I have as the answer, that it will be 17t squared out of t out of 2 plus 2 natural logarithm of t. You can also use the laws of logarithm, which means this can be a power of t, and so that's what I did, that if I'm using the laws of logarithm, then the 2 can come here as a power. So that's how we do integration by substitution. So I'll be doing more other examples on this before we go to another